My name is Sandeep Chandana. I'm with Snowflake. I'm on the corporate team that runs data science and machine learning for all of Snowflake, and we work very closely with the security organization there. In my previous life, I've been building security products that are powered by ML and stuff like that in the CASB space, CNAP and stuff like that. And today we are going to talk about how do you secure the modern data lakes. These are turning out to be behemoths of data. They're central to the data infrastructure and data strategy for any large enterprise. They're starting to play a more and more critical role, especially with the advent of Gen AI and LLM-based applications, which are extremely heavy on data, especially data that is probably not structured, data that is probably does not have all the bells and whistles that the conventional data repositories have, which data lakes have always been the source of. So we'll kind of get into the details here. Introduce yourself.
Thanks, everyone. Hey, my name is Gautam Kanaparthi. I'm a product advisor at Normalize. I've been in the cybersecurity space for the last 15 years, so built data security products across endpoint, email, web, SaaS, and so on. So very excited to talk about this topic today. I guess RSA saved the best topic for the last session. So let's get going. Standard disclaimer, you've probably seen this a while back. So in terms of the agenda, as Sandeep mentioned, before we dive into the actual challenges, we'll do a quick overview of how the data infrastructure has evolved, maybe look back at what data security used to look like, and then do a little bit of an architectural review of what modern data lakes are, how we are seeing organizations actually use them today, and then dive into the challenges and a couple of case studies and some best practices as well. Actually, a bunch of you may have some handouts with some best practices, so we'll go over them. And ideally, wrap it up with a few steps on how you can apply this in the next few weeks when you go back to work. So Sandeep, over to you.
Right. Thanks. So basically, we wanted to set the stage for why is this a problem? Why should you even care about it, right? Just looking at some of the data that we've been able to gather from our experience at Snowflake and what Normalize has been doing. There's about 400 odd data sources that bring data into a conventional enterprise data lake, right? And you're talking about, when I say data sources, these are not tables, these are not views, you're talking about complete application data that is moving in. So if you think about large organizations, and Snowflake can be an example of this, is there's a lot of data from the SaaS applications, the applications that power the business that are being brought into these data lakes for different reasons. You're talking about data enrichment, being able to tie data sources. You want a marketing campaign data to be able to go talk to the sales leads data campaigns, right? So how do you blend them all together? Not always do you have these applications talk to them. So the data lakes become central there. They are your sort of melting pot that bring the data in there, do the enrichments, push them back, reverse ETL, and things like that. So 400 odd data sources, you're talking about the complexity that comes in from the varying types of data that come in. There's no normalization there. It is used at different velocities and cadence. There is some data that could be log data, some data that's event data, and some data sets that are mostly trigger-based data sets, right? So how do you bring them all together and the complexity that comes through with it? 20% of the data that sits in the data lakes today. So when you look at a large enterprise, go from all of the business functions that they have, there is sales data, there is engineering data, there's security data, there's product telemetry, all of those things. About 20% of the data, rough estimate, sits inside of these data lakes. And these are placed into the data lakes either for the purpose of harnessing them downstream. They are data repositories for offline jobs, for research and development to happen on those data sets. There's different reasons. That's about 20% of utilization there, but what is anticipated at the rate at which it's growing, and especially as bringing this back to the generative AI applications and stuff, that number is going to be about 90%, because a lot of that data is going to be very easily found in the data lakes, and that's going to be the first home for data of that sorts. 7x growth in the data lake utilization itself. These are numbers that we're seeing generally from the amount of workloads that are being spawned off of the data lakes, the amount of downstream applications and jobs that are powered for data that is sitting in the data lakes themselves and not going into necessarily the structured data sources. And lastly, the Gen AI and BI. There is, I come from that background. My team builds a lot of these applications, and we are starting to see that shift where majority of the data that is powering these ML and AI applications, especially on the generative AI side, are coming from the data lakes. Again, that's because of how conventionally the data that the Gen AI applications are helping produce value out of were always sitting in these kind of data lakes. If you look at, in general, the data infrastructure itself, there was obviously the early days of on-prem legacy services. You're talking about data stores, racks even that housed a lot of this data. The next phase or the next wave of this was the proliferation of the SaaS applications, right? 2005, 2015 was the growth of the SaaS world. There's like literally everything that we did on the local devices now moved on to the SaaS world. The cloud was the biggest thing there. So a lot of the data proliferation happened through those SaaS applications. Then came the wave of the public infrastructure, the public clouds, with the AWS, Azure, and the GCPs of the world. All of the data that was getting stored there, the data that was being generated in these systems and things like that. And lastly, this phase that we are in, which is of hyperscale for data itself, and how does it get stored, how does it get evaluated and stuff. Platforms like Snowflake, Databricks, Redshift, BigQuery, these are becoming the central part of the strategy for almost all large enterprises. There would be, you'd hardly find an enterprise that probably doesn't have one of those hyperscale data platforms in their ecosystem.
I think one of the things just worth calling out is these represent what different kinds of tools existed, but they also kind of represent how the value and volume of data has shifted over the years. If you were to go back maybe 15 years, you would say most of my data is actually on-prem. To the point that Sandeep made earlier, now most of the data is actually moving into your data lake. So the velocity of data is actually higher in data lakes. And the business value of the data today is more in data lake than the data that's actually sitting on premises in some other database or some SharePoint or something like that.
Right.
So,
yeah, good.
I think in parallel to that, we also wanted to quickly look back how data security solutions have evolved over time, right? In a world where most of the data was on-prem, you could have done maybe an endpoint DLP, maybe a DLP for your network drive or something like that. But as data moved into SaaS applications, let's say with the proliferation of Office 365, Box, Dropbox, Salesforce, and so on, then came the CASB tools, the cloud access security brokers of the world, and their primary intent was to help you discover SaaS applications and the kind of data that's actually used in those SaaS applications, right? But that was not the end of the data platforms. Today, we are seeing data platforms in the cloud, public cloud, like AWS, GCP, and the data lakes of the world. So what we are seeing really is a preference towards one platform that does all your data security and data security needs. What we are seeing generally across the board is, hey, do I really need to add another data DLP solution for this silo? Do I really need to manage a different DLP solution, one for the endpoint, one for email, one for my network drive, one for SaaS application, one for IaaS, another one for data lake? So that's really where we are seeing the shift to, hey, I need one platform that addresses all my data security program needs. It doesn't matter where my data resides. It may move from one platform to another, but my data security should really remain constant. And that's where we are seeing the emergence of DSPM platforms.
For those of you, just to kind of bring everybody to the same page, the way the conventional data lakes that you think about today are, there is a central data store, right? This is where you have all of your data coming in. This is structured data. This can be unstructured data. This could be semi-structured data. This could be live feeds coming in. Anything that you want to have in there. And then there is a compute layer that sits on top of it. So the whole idea is you don't have to move the data in a traditional sense, move it into a compute cluster and run your applications and run your transformations in there. You're able to do that right in that the infrastructure itself. And then on the very top of that, you have all sorts of applications built on it. Like if you think about optimization applications, transactions, the aspects that are required for somebody to have the security and governance around this, the visibility, the data operations, data quality, all of those things are sort of value-added layer on the top of that. So what you have is a single place where all the way from getting the data and storing the data to getting compute and compute cycles out of that and producing value, all of those things sit in one place, right? That's the very promise of this. And which, going back to Gautam's point, is also why DSPM as our data security posture management is becoming more and more central, because as data is all kind of coming together into one place, both from a value standpoint and also from a consolidation standpoint, you want all your policies to be sitting in one place. You want the posture to be measured as a unison rather than trying to piece together a collage of different policies and different postures. So if you look at the different things that large enterprises, and I'm focusing on large enterprises, but this will apply to any sort of a data strategy. The reason data lakes are becoming more and more prominent are like some of these applications that are sitting out there, right? It's a centralized data repository. Like I said, you want initiatives that cut across different applications. You want to run programs that need to leverage data from different domains of the business. The data lake serves that purpose. Data exploration and research, it's really important. That's why we put it twice on that slide. That is another piece where people are trying to still understand what is that data. If you think about the general statistics, 80% of enterprise data is unstructured data that is not being mined today. It is being used for content generation, it is being used for different purposes, but it's not a part of the core insights that drive the organization, right? And that is where the data lakes will start to kind of help produce, get more value and things like that. Machine learning applications actually feed off of that. A lot of the machine learning applications that you've seen in the enterprise world will require large amounts of data. It is usually better served if it is sitting in one place. You need longer training windows, historic data, 6 months, 9 months, 18 months. The longer the time window of the data, the larger the amount of data, the better the models perform, right? So that it kind of helps there. Building platform native data applications. Like there is, even at Snowflake, we build a large number of applications that are native to the platform itself. These are data applications. These are not like the custom applications of the traditional world. These are applications that are helping drive business decisions. These are applications that help you protect the organization, kind of look at the trends in how the business is performing, all sorts of things that are being powered by native applications that are sitting there. And business and intelligence and analytics, this has been the traditional part, like reporting. How the health of the business metrics, customer sentiment, all sorts of analytics that needs to run. This data can now be sitting in here without constraints or restrictions of how you run these reports and stuff like that. And typically, you want to run these reports off of large data sets, so that's where it kind of helps. Yeah. So if you look at the native security controls that most of these platforms come with, most of the data lakes are automatically enabled with. I'll not go through the entire list, but single sign-on, multi-factor authentication. These are standard things like how do you control the authentication and authorization on the data, access control policies. How do you set up your RBAC? How do you enable data sets to be shared with some sense of governance that is partial access, right? Like row and column level access. Like how do I make sure that a certain team only has access to the obfuscated data, which is not PII? How do I make sure that a certain cut of the data, horizontal slice of the data is available to a certain function, not to others? So all of those things are typically enabled as native controls on these data platforms themselves, right? Things like data masking, bring your own keys, key management, all of these are sort of the bare minimum constructs that most of these data lakes come out of the box with. So if you look at the very bottom, like the native controls focus on the infrastructure. It kind of ensure that they piece together, or they give you the building blocks for you to piece together the enterprise security program itself. Like what are the different things that you want enabled? What are the different things that you want to have visibility around? There all can be enabled through these sort of native controls.
I think that's an important distinction to make. Is a lot of times we hear security practitioners and people that work on data lakes as well try to figure out, yeah, I have all these security controls from this native platform. Why do I still need something else? And that's kind of the point Sandeep was trying to make, is infrastructure security and access security is where those native controls tend to focus on. But you as a security team still need to figure out how do these controls align with what I want to achieve as part of my data security program. Does that align with all the data security controls that I have in other data storage infrastructure as well, right? So there's still work that the security team is responsible for at the end of the day. So you cannot just rely on what is available out of the box. You need to do a little bit more work beyond that as well, because not every use case that you have across your corporate policy is addressed by the native controls.
So that it's a good segue for like what are the challenges that exist despite of the native controls that come along with some of these platforms, right? So volume and velocity of the data that's getting ingested. Like if you think about a large enterprise, like I said, there's 400 to 700 different SaaS applications each of these enterprises are using. And there is a different rate at which the data is being produced in these different applications. You have sales applications that are probably updated by the sales staff, the field folks, probably once a day, once a week kind of thing. You have applications that are security applications that are gathering logs from the devices that are running within your enterprise. Those are generating multiple logs every second. right? You have applications that are custom applications internally being run. You have applications that your customers are using. So the veracity, the volume and the velocity of the data that is coming into these data lakes is phenomenal. And what that basically does is, how do you keep up with that data? Now, if you think about it, every new application that's rolled out, or like if you have a product feature, an enterprise product feature, every new rollout of the feature or even a small modification of that feature can produce a different set of product telemetry for you. And that telemetry could be of different sorts. They could be error logs that are coming in that may have PII data in that. So they could be logs that are high volume logs that have just changed overnight. Like, how do you keep up with all of those? That's one big challenge. The second one is the complex web of users. Like, if I can just sort of project this off of our experience at Snowflake, you have data scientists who need access to this data because they're building time series and forecasting models. You have security engineers who need access to this data because they're trying to do like threat detection, they're trying to do incident response. You have marketing folks who want to access to this data to be able to go target certain customers with new features that have come out. There is product managers who want access to this data because they want to be able to see how a certain feature is being adopted. When you look at all of these different use cases, it is different personas. It is different sort of applications of the data itself. And what that means is you need to enable that access in a different way. Like the product managers, because it's product telemetry, the data has to be sort of rinsed a certain way and like cleansed before it can actually be handed off. If it's a security logs, it is a different set of granularity of the data that you want to be able to produce. So the very nature of these users kind of makes it really difficult for managing this data without like a DSPM kind of a solution in place, right? Third-party access is something I missed, right? There are applications, and I'm sure like most of the enterprises have this, which are external third-party vendors who are hooking into your data lakes to provide value-added services. This could be sensitive data discovery, this could be enrichment, this could be data clean rooms, it could be a bunch of different reasons. And all of that data, how do you manage that access? And like it's almost like you have a dedicated service that is necessary, a set of admins and administrative oversight that you have to invest in to be able to make the data useful and functional to all of these use cases. Data classification, that's like with GDPR, with all of the regulatory frameworks that are coming around that have mandates on how certain data has to be handled, how certain data has to be stored, who gets access to it, what is the audit controls and compliance controls that need to be in place. Being able to sort of orchestrate all of that, the core tenet, at least something that we've identified at Snowflake, was our ability to classify the data. Like how reliably can we actually identify which data sits where, how sensitive is it, how do we classify it, how does it reflect back on like the internal enterprise data classification policies and stuff like that. So that is difficult, and being able to do this at a fast moving data sets, that makes it even more difficult. And the last one is compliance across that vast infrastructure, right? If you think about some of these platforms, you're talking about, just to give a Snowflake example, you're talking about like more than 100,000 tables that need to be monitored. You're talking about like hundreds of schemas that are spun up on a daily basis. Some persist for a long time, some don't. There are views that are created where data is being shared between two functional owners, like marketing trying to share data with the salespeople and stuff like that, right? Like how do you kind of make sure that the compliance framework or the visibility for how that data is being used and handled is consistent across the place, and you're actually able to report on that? Because almost all these cases, you have some sort of a regulatory body or external auditors where you want to be able to show that these are all the controls that we have in place and how are they being leveraged. So if you, this is kind of going back and specifically into the organizational structure itself. At Snowflake, what we have done is it's a centralized data engineering team that we have. This group is responsible for bringing data from all of these sources that we need to ingest data from. But what happens is the ownership of the data itself resides with the functional owner. So in our case, the functional owners are sales is a functional owner, marketing is one, finance is one. So all of these business units that own the data with a specific business outcome in mind are the ones who own these functional databases. Now, something that I've already mentioned this is these are traditionally data silos, but for the data lake to be functional and for the broader organization to get benefit from it, you want to be able to share the data across these functions. And that's where the organizational structure and how do you place that data in a way that can be shared and be benefited while maintaining the sanctity and the security required around that data it becomes important. Ownership and accountability of the data. despite of the ownership from a domain standpoint, what we've realized, and also talking to a lot of large enterprises, one of the challenges is to begin with, the data is owned by a functional individual or a functional team. Let's talk about sales, right? Now, with the growing number of sales applications, with the growing number of application owners, what it means is all of this data, the individual functional owner of that data may not have full control and full visibility and even agency on that data itself. So it starts to become a fragmented sense where some parts of the data is owned by individuals, some parts of the data is owned by individuals who do not fully understand the data, and that introduces challenges in terms of how you manage this data and what you do with it. And lastly, the operational overhead and how do you optimize all of this, right? Like if you think about, and I'll talk about this in the next slide as well, is the separation of duties. There are functional DB owners who are technically the custodians of the data, but then there are also people who are tasked with leveraging the benefits out of that data to be able to derive outcomes of that data. So if you think about marketing individuals, marketing data sets, while the responsibility from a DSPM standpoint is for the custodian to make sure that all the PII data or identifiable marketing campaigns are actually redacted so that way other teams don't have it. But if you kind of contrast that with the efficacy of a marketing campaign, it's important that you have this so that way you can actually run what you call targeted ad campaigns if you have to, right? So how do you make sure that the owners of the data and the administration of the data, there is good sense of separation of duties in that? Like that's a challenge in that. That also kind of extends into who's managing the access controls. Like there is just-in-time access controls. There is what you call access that is given permanently to service accounts. There is access that is given to third-party vendors who are connecting into this data for enrichment and stuff. How do you kind of make sure that across the time slice that all of these controls, the user access policies, they all remain cogent and current? From just a case study for like what we've kind of experienced. Like if you look at, this is partially inspired by, it's not one enterprise across a group of enterprises that like I've interacted with. There is no source of truth for what data is being stored. Like when you think about the engineering teams or the data engineering teams that are responsible for bringing the data into your data lake, they may or may not be sort of experts in the system itself, the upstream system. So they're bringing data blindly. There's an API that the what do you call it, app enables, and you're just pulling the data in. They're making sure that as much data as possible can land. The data is fresh, the data is current, and all of those things. But they don't really understand like what is that data actually holding on to, right? Similarly, the second aspect of this is upstream applications, and like in the call it new features, new capabilities, whatever it is increasing the amount of data that data that's produced. So if you think about an application like Microsoft Office 365, if there is three parts of that portfolio that the organization uses, now you add a fourth one to it that introduces a new data set. And the application owners may or may not be fully aware of what data it's pulling in and how does one cut of the data relate to the other cut of the data, right? So there's a lot of nuances that are sort of baked into how that data is brought in, which are not clear to everybody who's operating on that data. Overhead of security oversight, it bleeds in from that first topic itself, which is if you don't know what data sits in your data lakes, or if you're not fully aware of the classification on the data or the context of the data, how do you enable access control on top of it, right? Like so, it's you may not always have the visibility that you need. And with growing organizations, like Snowflake is a great example for this, is the way we have ramped up as an organization. The companies grow, therefore the number of employees grow, and what we've realized is the number of roles that are created to access these kind of things grow at a rate that's exponential to the growth of the users themselves, right? So what you end up having is the initial euphoria of enabling every employee in your organization to have access to the treasure trove of this data very quickly turns into a problem of managing access to all of this data, making sure that the right set of people have access. It is revoked when that use cases have kind of diminished and stuff like that. That's a really big challenge. The user landscape evolves in general. You have, for example, a team moves over from being a growth analytics team to a growth marketing team, right? So all of a sudden, their need of the data, their view of the data, and their utility of the data has completely changed. Now, who is responsible? If you think about it, it's dynamic, and some of these things happen over a matter of months, not even like years or quarters. So when that happens, it is what we've experienced is the data administrators end up always on a back foot. They're reacting to these kind of changes, and they're trying to make sure that while the organizational dynamics have moved along, they're still trying to catch up to making sure that the administrative posture of the data itself is catching up to that. Data governance and monitoring in general, this is for the sake of compliance, this is for the sake of certifications, this is assurance that enterprises have to give to their own customers. All of these things, there are hundreds of controls that are in place. Like if you think about Snowflake and some of the things that we've done, security of the data, security of the customer data especially is paramount. And when you're trying to kind of assure that what you end up having is also trying to comply with a bunch of certifications. Literally every country and every region has a certification and a regulatory requirement now, right? So being able to kind of cope with all of this, what that essentially ends up being is you have hundreds and hundreds of controls, and you need to be able to manage and monitor all of those controls. You need to make sure that those controls are current to the data and the posture that you have, right? All of those kind of are pretty much bleeding in from the fact that the data lakes are going hyperscale. There is a lot more orders of magnitude of data that is landing into these data lakes and stuff like that. Now, in terms of the desired solution, right? Like, what is it that would help us? Like, if I am one of those enterprise data owners, and like, what are the things that I would need to kind of create a cohesive platform that we kind of want to go off of? Sensitive data discovery. Like I said, that is the most important. Like for the most part, what we've realized is even the data that has been classified a week ago can change. Meaning that there's, like, especially with unstructured data or data that brings in user-generated content and stuff like that, it becomes really difficult for you to keep track of that. So it is really important that data classification is done on an ongoing basis, as fast and as frequently as possible, to be able to make sure that there is a good sense of what sensitive data sits where. Data type discovery baked into sensitive data discovery itself is what are the types of data, because your downstream processes for controlling the access to the data, to making sure the data is made available a certain way to a certain group of users. This could be masking, this could be, like I said, row level controls and all of that. All of that requires the knowledge of what are the data types, right? If I have to obfuscate data, if you have to do, for example, anonymization of the data, execute differential privacy, it's really important for us to know what data sits in there, not just the sensitivity of the data. So that's important there. Machine learning capabilities, as fond of machine learning I am, it brings in a lot of problems with that, because machine learning is usually focused on getting the insights out. It does not have a sense of how to handle data. It does not have a sense of maintaining the privacy of the data, making sure that the constructs of the data are not abused to an outcome that the machine learning algorithm or a model is driving, right? Like how do you kind of get a sense of all of that? Continuous discovery, like I said, like the need to keep up with the evolving nature of the data. There's a new data set that landed. What type of data is it? Who owns that data? What classification of the data is it? What is the retention of that? All of those things are changing by the source, are changing by the instance of the data that's getting stored. Enabling data protection, like I said, data classification is important, but once you've identified that this is sensitive data, then you can either leverage the native controls that the platform gives you for encryption, data masking, other data protection strategies that are in place. But it's important to have something like that. And there are a lot of the DSPM applications that are out there, DSPM vendors that are out there. They kind of let you borrow a hand from the native capabilities of the product itself. So you have a unified policy that is defined for data protection, but that can be enabled through the native controls of the platform or wherever the data is stored. Seamless access governance, again, this and also ties back to the being able to compliance for the data, enable scale, like efficient data discovery and stuff like that. These are all aspects where you want to, the traditional way of enabling access will not sort of conform to what the needs of the enterprise today are. essentially where we end up being is you want to be able to discover the data as fast as possible. There's more data coming in. There's a lot more consumers of the data. You want to be able to help them get benefit from that data as fast as possible. And that's where the data discovery becomes important. And access governance tends to be a blocker in that. So that's what you want to work against.
Just to add a quick point, I think for those that are familiar with the old school DLP and have run DLP programs like years ago, some of the themes may seem similar, but there's some nuances that are different around data lakes, right? You see callouts for scalability. Definitely the scale of the data in data lakes is much, much larger. So it's not like taking an old school DLP engine and putting it on top of a data lake. That wouldn't really work. The other piece here that is unique is the access governance, right? How complex the access governance is. In the old world, you probably could deploy an agent on the endpoint and it's basically blocking what it sees. But here in the data lake, fundamentally, you're trying to discover everything so you know what kind of sensitive data is where. Again, it's a matter of scale, but it's also some fundamental differences in approach to say, let me discover everything first, let me figure out who actually has access to what, and then start enforcing some data controls. So while the high-level topics may sound similar, there are significant differences, which is why the old school DLP solutions wouldn't really work in this particular case.
Right. And lastly, when you're evaluating a solution for this place, one of the biggest challenges is how do you classify data that you already don't know the labels for, right? So that's something that, for example, when we were doing, how do you identify a golden truth data set? Like you need to know if the sensitivity classification or the tags that are being produced, you have a ground truth to kind of go off of. Having a clearly documented evaluation criteria for how do you think about your DSPM, not as an application or as a problem, but as a strategy, right? Like what does what do you call data security mean to your organization, and how do you want to sort of characterize the quality or the maturity of where it stands, right? Like so, being able to have a clearly articulated way of defining it that is sort of agreed upon across the organization is an important starting point. And lastly, again, it is comes down to build versus buy, right? There are platforms, like we said, the data platforms that come with native controls that can be leveraged for this. So depending on what your use cases are, depending on what is the flexibility that you have in being able to extend these capabilities to suit your needs, it's a discussion between build versus buy.
I'll talk about case study 2. Case study 1, as I think Sandeep has hands-on experience there. Case study 2 is another customer that I work pretty closely with. A lot of the themes are similar. The core need starts from just the volume of data, where earlier we would probably talk in gigabytes. Now people are just talking in petabytes, right? It's not even terabytes anymore. There's tons and tons of data. So in this particular case, over 5 petabytes of data, and they had absolutely no visibility. So all of that was basically a black box. They did not know what kind of data was being put into that big repository, right? Again, the theme of user permissions is consistent across customers that are using data lakes. The volume of users and the complexity of user to specific data store permission and the levels of permissions is what makes it very hard for security team to monitor. It's not just enabling access, it's to say, okay, does this person, can they actually go edit PII? Can they read PII? Can they download it? Can they make changes to that PII? They need to understand it at that level. And the automatic role grants doesn't really help. So if a new employee joins and automatically the team they're part of gets granted to X number of roles, now they have access to a wide variety of data that they don't necessarily need, right? And lastly, the federated data ownership. So data is kind of interwoven, it's not just static. You may have access to a view, for example, that is consolidating data from 10 different tables, and they may not be sensitive in isolation, but when you put them all together, they actually may end up being super sensitive that you should not even have access to. How do you even get visibility to that? So in this particular customer's case, they didn't even understand that I actually have a scenario like this where sensitive data is inadvertently being exposed. Right? So even for them, as we talk to them and understand their need better, the desired solution was very similar. Start with classification, start with helping me understand what do I actually have? Do I really have a lot of PII? Is it PCI? Do I have data in regions where I should really be worried about? Am I under purview of GDPR? And how much of my data is actually there? And do that on a continuous basis. It cannot be a one-time exercise, right? One-time exercise is good for initial visibility for you to understand what is the scope of work, but you have to keep doing it on an ongoing basis. Access governance, it's very similar themes to Sandeep's use case there as well. I think scale stands out all the time. It's a matter of, even if you have a scanning engine, can it actually scale to petabytes of data? How long does it take? You can't afford to run scans for months on end and incur those costs to understand it. So being able to run that very quickly and efficiently from a cost perspective as well is a big criteria. So at the end of the implementation, they went with the DSPM platform as well. When they did the initial audit, what they found was they actually had 3x more data than they expected. They had databases that they didn't even know they actually had. And they realized a vast majority of the users actually have access to sensitive data. In their case, it was PII, right? And these were fundamentally things that the security team was not even in the loop, and they were not even aware that this was actually happening in their environment. And they ended up prioritizing PII. For them, that was the most valuable set of data. For you, it may be something else, but you ought to start with an initial audit and understanding what you actually have. And they use this insights to identify what are the unused access privileges. So they really wanted to enforce least privilege across the board. So they went about understanding, okay, I have all these privileges, but who is actually using them? And if they're using them, how recently have they used, how often they have they used, so they can right-size the permission set. But the fundamental visibility helped them make those decisions and put them in place. And lastly, they chose to incorporate auto-remediation, meaning if they already knew something was an issue and there was a documented process on what exactly to do in this particular scenario, they could put the remediation in place to say, for example, if I see a new user coming in that is part of X group and they have access to PII, and I would want them to have access to PII, revoke that access, for example. Right? So the key thing, as you've seen and we've talked about earlier, all of these are not just challenges in silos with data lakes, right? There are definitely nuances, but if you look at it from an overall data security program perspective, all of these are similar themes, similar challenges that you would run and encounter in other places where you store data. Definitely the data lakes take it to another level in terms of scale. So as you think about what you do for data security for your data lakes, make sure it is in alignment with what you do for data security across the board. You cannot have, again, a data security program for each surface where you're storing data. It has to align with the overall data security program, right? Whether it is about classification, do you have a standard classification nomenclature? Do you have standardized workflows? If you find sensitive data, are you following the same processes across the board? And how are you actually monitoring and enforcing compliance? All of those should be pretty similar across the board and not just unique to the data lake. So Sandeep, I'll kind of build this out and then you can talk through this.
In terms of the best practices, right? Like, and these are lessons from what we have learned. These are things that we've seen across large organizations and stuff. I'll read the first one out. Like, understand and clearly enumerate your sensitive data classification requirements. Like, to the earlier point that we said is, across the organization, given the nature of your business, given the nature of the data that is brought into the data lake, there are variations in how you define the sensitive data policies. So being able to have a consistent policy that can be applied in a simplistic fashion across the organization is really important. Again, like, PII, find all PII, that seems to be the flavor of sensitive data discovery, but there's a lot more to be able to understand, like, which data types have what implications and how they can be used. Ensure all compliance requirements are identified. Again, this is, got to do with the business and the markets that the enterprise operates in. So if you have regulatory requirements that are specific to your industry or regulatory requirements that are specific to the geography that you operate in, being able to have a good sense of a running up-to-date list of all the compliance controls that are necessary, that's important. And finally, confirm the capabilities that the platform natively comes with, right? They tend to be easy to use, they tend to be efficient, but they also tend to be limited in the scope. So it's out of prudence that you have to kind of go get a good sense of what are the limitations of the basic capabilities that these platforms enable natively.
And just a quick call out to one of the earlier points from Sandeep. I think having a point of view on false positive versus false negative is definitely important. We've seen organizations where false positive is really bad, but we've also seen organizations where, hey, I don't want to absolutely miss anything. When I tell an auditor that I don't have PII in a certain data store, I want to be 100% confident there's absolutely no PII. So in that case, you don't want false negatives, right? So it may differ based on the organization, based on the industry you're in. So that's something to think about, especially as you are trying to put in some kind of data classification engine in there, so you know what to optimize for.
where a false positive will translate into some sort of friction in getting an insight or getting an app out. A false negative is basically a data leak, right? So the implications are vastly different.
So, yeah, I think we talked through that.
Yeah. In terms of kind of keeping up with the same thing is monitoring of access privileges, right? Like to what Gautam said, a lot of the organizations, just by the virtue of how the data has evolved, users have evolved, and their user requirements have evolved, there's some general stats out there that will tell you that about 90% of the access that's been granted to an enterprise user is not leveraged on a day-to-day basis, right? So this is essentially data that can be exposed. This is data that can fall into the wrong hands or be, is out there. So there is an absolute necessity that there is some system that's in place that evaluates every individual's access, especially to the sensitive data, and make sure that it is cut to size. Like there's trim out as much fat as possible. Enforcing least privilege. By default, a lot of organizations under the aegis of making data available and being data driven take on the path of least resistance, and they're like, we'll give everybody access to all sorts of data, and then we'll pull back on a need basis. It should actually be turned that should be turned on its head. What you want to do is least privilege. You don't want to sort of proliferate access to the data, especially if it is sensitive data, especially if you don't know, your chickens or your data in this case. Ongoing monitoring, again, like for all aspects of what data comes in, like I said, like the velocity and the veracity of the data that lands into these data lakes is insane. So how do you make sure that there is some sense of a pulse of all the new data, the new tables that are getting created, the new data shares that are being enabled, even the roles that inherit sensitive data roles and stuff like that. Like, how do you keep a check on all of these? Escalation of privileges. These are all aspects that are granular, but they need to be looked at on a regular basis to make sure that none of them becomes a big gaping hole. Lastly, what we've been calling out, like the data security program, right? Like, so this is independent of the platform. This is independent of how you enforce data classification, or how do you sort of apply data classification, use it downstream and stuff like. But having a cohesive data security program, having all the stakeholders in the same room and kind of align on what that is and how do you want to go about it, and especially being practical about what you can achieve. Like this data security program cannot be overhauled overnight, right? So how do you kind of pave the way and like you set your milestones so that you get to that final ideal state in a fashion that does not impact productivity of the organization, does not impact the top line or the bottom line for your business, but kind of ensures that you do this while making sure you don't rock the boat. Clarifying ownership and responsibilities, it's a part of that security data program. Like for example, at Snowflake, we have a very clearly defined RACI against all of our data stores. Who owns them, who acts on them, who consults on them, right? Who is responsible for the individual pieces. Even in the responsibility matrix, it is what aspects of data security does one group own versus what aspects of the responsibility does the other group own, right? Like, so all of those things, being able to clearly lay that out and have everybody kind of attest to that, the accountability and the transparency in the process makes it even more easy to kind of enforce and implement all of these. And lastly, being able to not just monitor but act on it, right? Have provisions, have processes in place so that you're not reacting to incidents, you're not reacting to data leaks and stuff like that, or new findings, but you kind of have a process of responding to them.
Great. So I know there's a lot of jargon generally thrown around in the security industry, but for data lakes, I think following these best practices should serve you well. So if you kind of go back to work and think about what to do for data security, this is our recommendation, right? So in the next week, you could start with an audit of your data lake. Like we talked about in the case studies earlier, start always with an audit. So understand what you actually have first before you dive into further details. And then you can figure out, okay, where to prioritize, which data store to prioritize, which parts of the data lake do we even start with. You don't have to boil the ocean and start with the entire repository of the data lake at the same time. So in the first 3 months, you could then do a comprehensive discovery. Maybe you find out that you have a lot of PII, dive into PII, dive into what types of PII do I have, who actually has access to that, how is it actually coming in. So you have a full catalog of inventory. And you also understand what is the rate at which that's changing. Are you seeing a lot of new data stores being created with PII? So that should take you the first 3 months to kind of get a full understanding of how your data is evolving, where it is being created, and what kind of data and access and so on. And then you can do a full inventory and understand who are the users, what are the privileges, are they changing rapidly, are they actually being used, and then start putting some controls around enforcing the principle of least privilege. And post that, you could do other things around operationalizing your data security to the fullest, right? So you could drive operational projects to say, I want to now discover sensitive data everywhere in my data lake. I want to see where else it's coming from. Let me also go incorporate a data security program over there. Actually act on it, proactively monitor rather than trying to reactively understand what has happened. Anything new that is created should automatically be fed in. You're ideally integrating them into your remediation process. People are getting notified when something is sensitive that is found, and if some violation happens with the user privileges, that should automatically be triaged and created a ticket for the team and so on. So, but that should probably be like 6 months or so. But you could start with a quick audit so you know how severe the problem is or how much time you need to spend, and then go from there. Right. So Sandeep, in your experience, does this align with how you approach as well?
Just to, based on our experience working with a lot of customers and large enterprises, what we've seen is the first two kind of drive all the program forward. The minute you've identified what all data you have and the amount of sensitive data that's out there and how many people have access to it, that is a driving force in itself. Like usually the program gets into an autopilot mode that point forward. So the things that you do in the first week and the first 3 months, they can, depending on the level of maturity of your data security program, it can be daunting and it can be frightening, to be completely honest, but that will drive the program forward, and that, because everybody wants to be sure about the data. So it will go on autopilot.
Great. So kind of to summarize what we've discussed so far, I don't think the data lakes are going away anytime soon. They're in fact hyperscale at this point, right? So similar to how AWS, Azure, and GCP are, like Snowflake, Databricks of the world, the data gravity is only increasing in those platforms. And I think we touched on this a few times. So the legacy solutions and how they approach DLP doesn't really work in the world of the cloud and cloud native data lakes, really. The scale is just too massive for them to really scale as the classification engines. But at the same time, discovery and classification is critical. So you need really native classification solutions. But don't just focus on classification. You got to think about the data security, the entire spectrum. Think about access governance. Think about how do I detect risk to my data? How am I actually ensuring compliance for data that's going in data lakes? And align it with the broader security program. Don't just do this as a siloed data security initiative for the data lakes. This has to align with your overall data security program, right? And then this is maybe critical, and Sandeep, you may have thoughts on this. I think where we've seen security teams be successful is when they've positioned this as an enabler for initiatives, especially we are seeing a lot of talk around Gen AI and a lot of AI initiatives. So data security team could really be the enabler of initiatives rather than blocking somebody from doing what they want to do with AI applications.
It really helps in if you're partnering with the data and AI initiatives and taking a sort of a proactive approach to say that, like, these are some of the applications and these are some of the use cases that will come out of this. Can be, if you can be creative and imaginative about that, being able to preemptively unblock access to this kind of programs, that'll win hearts, and you'll have more partners in enabling the program.
And start with an audit. You don't have to boil the ocean. Start with a small audit and then go from there. The best practices, again, the slides will be posted. You'll have access to it. We also had some handouts. A few folks may be missing them. But if you need a handout, Normalize has them on their website, normalize.ai, and you can get a deep dive on best practices for Snowflake as well, right? If you have any questions, you can use the microphones, or even later, you could reach out to Sandeep or me for more a deep dive conversation.
And I think we are at time, but we're happy to hang around.
All right, thank you everyone for your time.
Thank you everyone.